you want to go over any of these? Which one? 45. 45, that sounds like a good one.
I didn't know. It's not a good one.
No, I'm sure.
Okay. Picture.
So just to double check,
same thing, right?
Mario.
What's
the one that Evan and I were trying to go over.
What does it say?
So, it's number 45.
Cosine, cotangent, x.
Yeah. So, anyway, in this one, they have decided that it would be a good idea to multiply by a form of 1, okay? And so when you look through that list from 5-2, and we said, how might you go about proving this? One of the ideas, and this is what I did, was...
This from 5-2.
Yeah.
That's why this was so hard.
One of the ideas was to make a common denominator. Tried that, didn't work, okay? Then the other one was multiplied by the conjugate, which would have been 1 plus tangent, and that almost worked, okay? But then in this one, we actually were supposed to multiply by a form of 1, and then if you look down here, they wanted you to end up using that algebraic idea of a difference of cubes. So the fact that a difference of cubes has the two things that are being cubed, subtracted, and then a squared plus them being multiplied plus the other part squared. So, I know. Either way, it's all factoring. Okay. So in that case, they took the first one and decided to multiply it by sine over sine, because then they end up getting a denominator that is pretty much the same, so they multiply it across. So, sine over sine, because once you multiply sine by 1 minus cotangent, you get sine minus cosine, which is a lot easier to look at than 1 minus cotangent. Because basically anything with cotangent or the reciprocal trig is kind of weird. And then over here, multiplied by cosine in the denominator and the numerator, and so then you end up with cosine minus sine. Then they decided to multiply by another form of 1, so sine x cosine x over sine x cosine x, so that again they could get this piece, which was the whole idea, to get something cubed minus something cubed, so that they could use this unfactoring, or this factoring. So these two things cubed with the subtraction between them actually becomes this thing with another sine x minus cosine x. They're just not showing you the step that they canceled the sine x minus cosine x. So from this step to this step, they factored and canceled. All right, so then this was potentially on top with that, but canceled. Then they moved on to the next piece and decided to, what did they do here? Oh, wait, nope, that didn't happen. Let's see, how do they get from here to here? Oh, cosine squared plus sine squared is 1 for mere Pythagorean identity. And then there's still sine x cosine x. And so taking a look at that 1, anytime you have a fraction, you can do the piece over the denominator and the other piece over the denominator, the terms. And so they did 1 over the denominator and then the same thing over the denominator, so it became 1. And then 1 over sine becomes cosecant, and 1 over cosine becomes secant, plus 1. In case you're wondering, I had a note that I should have changed this assignment from 11 to 39 instead.
Oh my God!
Basically anything after 39 was very hard, and so gave for you if you did it.
I only did it to 39. I did it to 51. I didn't even have the sheet.
Oh, well,
So if I haven't done it
seeing
yet.
as if I haven't done it.
I literally just, so you should go to
Wait, no, you didn't do that. You just
I wrote a tiny little note to myself, change assignment to 11 through 39, but I didn't see that until just now.
So now I know that's 6 hours of work.
Well, I don't know why you spend 6 hours
Well,
on it.
maybe you should
Because
make
remember,
money and not do a third of it because you want to draw.
Yeah, I don't look that close.
Yeah. Don't you?
Guys, he just needs to make sure there's a large.
I remember,
Yeah.
Maggie, I remember when, like, last year you were like, if you spend more than an hour of work on this, just don't do
Then you
it.
should be done.
Right.
Mhm. Yeah. Yeah.
We go over 29, 31. This is the first time
They got stumped.
Okay.
More having bobby pins.
No.
Okay, that did not, I heard, does 31 have any bobby pins?
No,
Not
I want bobby pins.
no.
Just for fun?
No, turn around, let
To keep that. Okay, so this
Well, that makes sense.
29 is over here. There it is. Okay.
It's really
Stuck over there. All right, so 29's got cotangent squared, cosecant squared. And so when I'm seeing this, I'm thinking that we probably want to rewrite it as sines and cosines because there's a cotangent. I also see that because they're both squared, it might be nice to do some Pythagorean identities. So if rewriting it as sine and cosine doesn't work, then I would try that step. So cotangent squared becomes cosine over sine because it's the inverse of tangent or the flip of tangent. Then we get squared still, and then they kept that way. Super. So they rewrote it as cosines and sines. Then they factored out a cosine of this numerator and this numerator, and ended up with, and multiplied this by a sine. Oh, that's what they did. They just changed it into a common denominator. So they multiplied this side by sine squared of x. And then in that same process, because you couldn't just do one step in one step, they also took out the cosine squared of the numerator. So cosine squared from here left a 1, cosine squared from here left a sine squared. 1 minus sine. Then we realized that 1 minus sine squared is cosine squared from your Pythagorean identity. So this equals that. Yay. And then we have a cosine squared left, which becomes cosine squared, and cotangent from that one. So the identities here was changing it to cosines and sines, multiplying the second one by a form of 1, a Pythagorean identity there, and then simplifying. So that was 29. Any hints on what part got you funkified? What did you try, Max? Oh, okay.
The reason why I didn't equal 31 is I never saw anything about cosine to the power 4 on the sheet.
Oh, about 31?
Yeah.
Yep, and so that's because you have to change them to imagining it's x to the 4th minus y to the 4th, and then you can change that to difference of squares, which is x squared minus y squared, x squared plus y squared. So it's just the factoring idea that if you have difference of something that could be squared, you get to have a plus and a minus of the two square roots. So, yep, no fourths because they came from squares. Yes, Izzy.
For 29, I did something different, but I got the same answer.
Perfect.
So there's one more way to do it.
Oh, yeah.
Okay, good.
Yep, definitely.
Can we do 37, please?
Sure.
I didn't like
Okay. Well, in that case, definitely gonna do it. All right. Okay, how do I scroll over there? Oh my God.
Okay, bye.
Oh, there we go.
Bye.
Got it. Oh,
I'll
bye.
pick up my father.
Oh,
So
that's
strong. So
different. Okay.
it's not even a joke.
All right, so number 37. Okay, erased it off. All right, so number 37, I assume, looks like they multiplied by a form of 1. Sounds good. I personally would have multiplied by its reciprocal because that feels like it should happen. But I guess it's the reciprocal to, or the conjugate, sorry, to the numerator. So they saw this negative sign and decided to do sine of x plus cosine of x so that they could take a few of those terms out, but then had to multiply the same thing, of course, on bottom to this denominator. So now there's 2 of them because of squared. But then the numerator had the minus and the plus. And so when you factor that out, you get sine squared, cosine squared, and the middle terms cancel because you get a negative cosine sign and a positive cosine sign. So those would cancel.
Positive.
Yeah, and then, for fun, they factored out the denominator as well. But that one, because they're both pluses, don't cancel any of the terms. so that didn't work. And then they decided, again, like always, that cosine squared plus sine squared is 1, because it is in your Pythagorean identity. Then, what happened in the numerator? What? Okay, so that's there. Sine squared. Oh, they took another Pythagorean identity and rewrote cosine squared as 1 minus sine squared. Okay. Then to get from here to here, which is the result that they wanted to get, you've got the signs that come together because it's -1 and negative sign. So you get 2 signs and -1, and then the bottom is still what they wanted it to be, 1 plus 2 sine x cosine x. So distribute the negative and combine like terms on top. That's why they get the next step. So, again, this is going to be obnoxious as you work through it because you just kind of go through that list. Should I multiply by a sum of 1? Sure. Should I rewrite it as sines and cosines? Well, it already is. Should I multiply by the conjugate? It's just a checklist, which eventually you could, for instance, this assignment could have gone really well if you randomly picked the right one all the time. But of course, that's not going to happen. So instead, you kind of have to remember that anytime you see a squared, maybe you can use the Pythagorean identity. Anytime you see a fraction, you can try to do something with the denominator. So it's just a trial and error, which is why it sucks a lot. All right, so all of these again are worked out, and this is where I just have a little public service announcement. Try to actually show all of your steps, because if this was like a test problem, and I can't see how you get from the one step to the next very easily, other than you writing out what it is, just make sure that you do show all the steps, which I do in class, so you kind of see how you should do that, but really you shouldn't overly simplify as you work through, because otherwise I'll miss something. If I think it's wrong or that you made up a step or something on the test, I will come back and ask you, like, how did you get from here to here? And then you can explain it versus me guess. So, not a huge problem, but. All right. So, today's kind of more of the same, only now we're going to add some more identities. So, to use. Yeah, it gets bad. So, not today though. It is not as bad as it could get. All right. So don't even worry about it.
The worst is
Yeah, the worst is
Can't wait.
I know. Okay. So let's pull up the 5-3 notes. And you should get out your formula sheet so we can kind of look at the next piece.
This is fantastic.
Wait, I lied. It's in my textbook.
Yay! That is an excellent place to keep papers. Okay, there it is. Ha! Sum and difference identities.
We are not the same.
So, chapter 5 is all about proofs. So, sorry. Maggie. Trig proofs. Everyone loved trig, and then now you don't.
I didn't love
I
trig.
didn't love trig and I hated proofs in the first place.
We're starting trig in geometry right now, and it's just so exciting. That's all I
My cousin is like a month older than me and he's already in like Calc 3. And
Well, I mean,
Everyone is at
try not to compare yourself. You are you.
we were
Okay?
both homeschooled for the same amount of time.
Mm,
Some people are just
by the
smarter.
same person, because that could
No,
change it.
actually his mom is mean.
Oh, his mom is mean.
Oh, my mom is also mean, but his
Oh.
mom is like constant.
Well, maybe that's how he got further ahead, because he got yelled at a lot more.
Yeah.
Or some people
Yeah,
are
the
just
Sean
smarter.
made him study harder.
Yeah, there you go. Okay, so this one gets kind of clever, okay? Because what's going to happen is you're going to get something like cosine of 20 degrees. And the idea is that you don't have a 20 degree on your circle, okay? And so instead, you're going to try to make 20 degrees by adding or subtracting 2 degrees that you actually already have. So, for instance, on your unit circle, you have 30 degrees and 45 and 60 and 90. And I don't know that any of them are 20 degrees away from each other, so I made a bad example. Is that 30? Yeah, we'll make it 30. Okay.
How about 15?
Right. And so if you make it cosine of 30, you can instead say that 30 is actually 90 minus 60, which, okay, it's already on the thing, so anyway. So you could do 90 minus 60, which means that you would do cosine of 90, because that's what I've written as the u, cosine of 60 plus sine of u, which is 90, and sine of 60. And so instead of doing cosine of 30, which is already on the thing, yeah, okay. The idea is to get the number from two other numbers that are already on there. So, yeah.
So is that a plus or minus between the two cosines?
Yeah, and so that's why your chart is different, because it turns out that if you want u plus v, that's the top symbol, you're going to use minus between them because it's also the top symbol. So I just went ahead and rewrote them on exactly how they are because this was a weird symbol set. It's basically to save ink from them having to write it twice. So, sorry. So you already have it written twice on your formula sheet. So. All right. Same thing happens here. If you have a sign that's added, you're going to add the sine, cosine, cosine, sine. We used to have this chant in my pre-calc class, which was like sine, cosine, cosine, sine, cosine, 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 sine. To remember these, which I'm sorry that I had to do that for you, but
I like
yeah. Sine, cosine, cosine, sine, cosine, cosine, sine. You had to remember though which one was which, right? It's clearly, yeah. Okay.
easy to mix up.
Very much. We didn't have a chant for tangents, so sorry about that.
That
Okay.
was the hardest too.
Yeah. Well, it's just
You just divide.
twice. Yeah. So tangent, of course, is sine over cosine, so you just get to do the sine one and the cosine one at the fraction. So should be okay. But if you don't want to do the sine and cosine separately, you can skip all the way down to here where they already do it for you and say that you can do tangent of u plus tangent of v and then 1 minus tangent of u if you do that. So again, on your piece of paper, I've written it out twice here with the proper symbols twice and then this twice as well for sum and difference identities.
Oh, because I remember looking at it and going, oh no.
Oh yeah, it's not so bad. So really, you're just identifying u and v, meaning which two degree measures that we already know. So you're going to be using 30 and 45 and 60 and 90. And you're going to use combinations of all of these numbers to try to get the number that they're giving you. So when it says use sum and difference identities, this is what it means.
Maggie, when are we gonna have to do this?
Later.
But like when?
It's like a section a day, so probably, 5. I'm guessing. I'm guessing. Okay, so here we are with something that's very big that I want to make smaller. Where did okay, well, maybe not. Okay. Alrighty, so we're going to find the sum and difference, and of course they give you radians, which if you are not super excited about, you can change to degrees. If I can scoot this over again. Oh my gosh. Come on, Maggie. Get your idea. There. All right, so the first sign that they give you, or the first measurement, is 13 pi over 12, which is really neither here nor there unless you love radians. So 13 pi over 12 can be changed by multiplying by 180 over pi, a special form of 1 for pre-calc. So we technically would cancel the pi's, and so we just need to know what 13 times 180 divided by 12 is.
Okay.
Is 2,000 what?
340.
Oh, and then you divide that by 12?
Yeah.
Okay. So maybe not.
That divided by 12 is 195.
Ooh, like it. Okay. So 195 is not a meeting point on the unit circle. So we have to take all those numbers of 45 and 60 and all of these things and either add them together to make something or subtract them. So most people don't subtract, but I'll try to, so let's see. 210 minus 15, well that's not in the unit circle. 225 minus 30, okay. So we're gonna do 225 degrees minus 30, because that's 195. So this is actually asking what is sine of
Why
195.
would you use the difference identity instead of that? Sum right there.
Because most people automatically think of adding two numbers, and so if I do subtraction, maybe you'll remember that more later. Because either works, and you're gonna come to one that can't add, and you're gonna wonder, well, then nothing works, but you should subtract. So 225 minus 30 is 195, and so now we're gonna use the sine identity to figure out what this actually is without a calculator. So yay for us. So we're gonna do, let's see. I think it's, let's see if I can remember. Sine of 225, cosine of, no, I can't remember. It's all.
Were you using a calculator?
No, I just need the formula sheet. I was doing my chant, but you gotta
We could
remember
have
it.
told you.
I know. What is it? Cosine of, oh, u and v. Okay, so 30 minus cosine of u, which is 225, times sine of v, which is 30. Let's just double check that's it. U minus v.
Song that you said is actually really sticking.
Yeah, it is.
I
don't
know.
remember it. It left
But
me.
you have to like remember which one
Cosine,
adds
cosine,
and.
Sine,
Sine, cosine, cosine, sine, cosine, cosine, sine,
Sine,
sine.
sine.
Yeah, but
Ah.
how do you know what's adding or subtracting
I have no
which one is
idea.
which? Yeah, I know.
I just remember the
So so from that I knew that sine was supposed to be sine, like both of them separate, but that's all I could remember, so it wasn't really helpful. And then I didn't know if it was u and v and v, or if it's u, v, yeah,
I'm
anyway.
just gonna support
Yeah, I know, me too.
I like
Yeah, so then we're actually gonna find these. So sine of 225 is something exciting. 225 is a half, negative a half.
My last day, bye.
Oh,
I know.
okay. What is my stapler gonna do without you?
I don't know. What does?
Okay, well, be careful.
Yep.
Go forth and prosper. All right, cosine is square root of 3 over 2, unless it's not, okay. And then cosine of 225
Did that get you?
is
It gets us
negative,
every time.
surprising me. He's so close.
He really is.
and sine of 30. Did I do that? Right, yeah, cosine.
He wants to be close to you, Lex.
I keep forgetting.
What's happening?
Lex, just show back. I was just show back. No context.
Oh,
Ready?
I did it wrong, yeah.
It's Gordon Ramsay.
Oh! that was really bad cooking. Tastes terrible.
That's close enough.
Yeah.
So much oil. America would have made it.
So it turns out 225 is square root of 2 over 2, so yay. And then just double checking, oh, wait, so this is sine. Good lord, maybe.
This is my favorite too. That's your favorite too.
Okay.
He's so close.
So this is where it's gonna get a little difficult, okay? So what happens is you are going to simplify this as much as you possibly can, which might be different than others. It's the log in again. So for instance, yay, common denominators, not that it matters because it's multiplying, but square root of 2 times square root of 3 is going to be square root of 6. And then 2 times 2 is your 4.
Oh,
And then minus a negative, so we're going to plus
it just.
square root of 2 over 4. And then they have the same denominator, so you're going to write negative square root of 6 plus the square root of 2 over 4 And we can't really simplify it a whole lot more after that. However, a lot of you will at this point just get a decimal, which is what we don't want.
Maggie, I want you to know that when you said negative square root of 6 plus square root of 2, I was going to say negative square root of 4.
Oh, 4.
Which
Oh. Yeah, that used to be what we did. Yeah, so that's not how it works. I suppose, yeah, no, it really doesn't work out. So this is going to be most likely what your book will have as an answer. You're probably going to have a decimal. So just take this number, add it to that one, divide by 4, and compare that your decimal matches.
Wait, why wouldn't we just get that?
Well, depending on how good you are at simplifying your radicals, you might not have exactly what they have.
Oh.
Yeah, so it's always easier to just compare decimals. Also, if you start getting a decimal, that's annoying because the whole point was that you did it without a calculator. So anyway, so see if you can actually, because we have gone over simplifying radicals, at least in Algebra 2. See if you can get there and see how it got there. All right, so then without doing all of the effort, because no thanks, how would you get a tangent of 105? It would be what plus or minus what? So that it could be on the unit circle. What two values are you going to use to make 105?
I'm thinking, Maggie.
I'm thinking 60 and 45.
That was me too, yep. So tangent of 60 plus tangent of 45 is going to kind of go with the fact that 60 plus 45 is 105. So then your u would be 60, your v would be 45, and you can plug it into the formula and solve that way. So that is the plan. And if you want to see that one work through, you can go to the notes on it, but clearly you plug it into a formula. All right. So then they want you to use those identities to work backwards. So now they're saying, hey, look, we've written sines and cosines and there's a bunch of angles, but we would like you to instead write it as a singular sine or cosine or tangent.
Add the sine and cosine.
Well, so we're not going, they don't want a number, they want it as sine or cosine of something. So before we get too far, again, it's probably going to be hard if we don't have these as degrees, unless you love radians. So pi over 3 is going to be 60. Yeah. So it's actually sine of 60. And pi over 7
Excuse me, I'm sorry.
is so not on our unit circle. Okay, so let's convert pi over 7 into radians, or sorry, degrees. 180 over 7. Sure, that's good.
What's the answer?
Gordon. Oh, that's a not good number.
Gordon, right?
Yeah, it's
This is a
not.
bad thing.
That's
That's a different show.
cosine of
Sorry about
25.71. Okay, so 25.71 cosine of 60. Okay, so this one is obnoxious because it's not actually one of the degrees, but that's not what we're looking for. So on that note, we have to figure out, is this going to be sine or cosine? Which one has a sine with a cosine being multiplied versus the sine with the sine and the cosine with the cosine?
Hey, Lex, you should put your home screen to be a zoomed in picture of Mary Berry's face.
That's actually
All
really
right,
good.
so it looks like the cosines have, the cosine of a angle I added has sines together and then cosines together, and so clearly it's not going to be a cosine, it's going to be a sine. And then you have to identify what is u and what is v, and they do put them backwards, so that does not match what we have, because I tried to put them the same way. Plus they're subtracting, so that means it's sine subtracting two angles. And so our u value is 60, and our v value is 25. So u is 60, v is 25.71, which means that it came from sine of 60 minus 25.71, or pi over 3 minus pi over 7.
So low quality.
And so sine of 60 minus sine of 25.71 means that this entire thing could actually have been written as sine of 34.329. I wonder if pi over 3 minus pi over 7 is easier. I doubt it. But you never know. 7 minus 3 is 4 pi over 21. No, seriously not on the unit circle. Okay.
4 pi over 21.
So, but more accurate than decimals, so.
That one was too weird.
Yeah. Okay, so in case you were wondering, sine of 4 pi over 21. Super. And again, most of the time, if it's given in radians, it's best to give the answer back in radians, because it's kind of like answering in a different language if you did that. Also, anytime that you have decimals, it's best to keep it as a fraction if you can, so that would be that one. All right, then clearly in part B, we're using tangent. Who knew? But we need to be able to rewrite this as tangent of one value. And in this case, the value is not necessarily a degree, it's a expression. Yes. Let's see. We've got plus, and so U is 3A, and V is 2B. Yeah. So just 3A plus 2B. Yep. Because they just want a single tangent. Yay, single tangent, rather than all of that. Okay. So that is your sum and difference identities. So now we are going to go through proving actually a co-function identity. Because if you look underneath the more Pythagorean identities on your formula sheet, there are co-function identities. And of course, the way that you can prove that this works is to actually solve it, okay? And that's also another thing about having a formula sheet, is that a lot of times, as long as you remember the basics, like tangent is sine over
It says
cosine.
it works, so it works.
Yeah, but like that, if you remember back to geometry,
I don't.
when we proved things that felt like they were just logic,
I put that
it happens. So, as much as because I typed it and it's right, we are going to actually prove this one. So, the way that we're going to prove this one is the fact that we have something minus another something inside of a cosine. So we're going to use our addition of sine identity. Addition of cosine. So the u value is going to be pi over 2, which is 90 degrees. And the v value is going to be x. And we're going to try to make it eventually just simplify to be sine. It's going to be great, guys. It's going to simplify. So, looking at our identity of cosine subtracting two pieces, that's cosecant, where are we? Cosine. Oh, literally. Okay, so, har. Cosine of x. And then plus sine of u, which is pi over 2, minus sine of x. And by minus, I mean not minus anytime. So cosine of pi over 2, which is the u, times cosine of the v, plus sine of the u times sine of v. Okay. And again, remember that pi over 2 is 90 degrees, so if you're thinking of what those values are, what does cosine of 90 degrees equal? How far over do you go to get up to 90 degrees? None. So 0 times cosine of x plus what's sine of 90?
1.
1 times sine of x. And so notice that this becomes nada, and this becomes
sine.
sine.
0
and-
plus sine equals sine,
yeah.
and that's how you get the sine. Meg is a genius.
Yeah. No. All right. So.
Wow, math.
Yay, math works. I know. So you'll have to do a few of these, I know, on your assignment where they're asking you to prove that. And so you're going to be proving one of the ones that's on here or one like it, again, just by using the formula. So, yay, sine. Thank you. Okay. All right. Not sure what's next, but I'm really excited. Okay, so here's another one. Honestly, I'm pretty sure we can all insert x's in pi's over 4, so let's move on.
Okay.
Uh-huh.
Do you consider math art?
Yes, because sometimes it's super beautiful and lovely to look at.
Is that what defines art?
Wait.
To me.
Yeah.
I don't know.
This is an Ian question.
That's fair.
That's an Ian
I don't know,
question.
Lex, how about you define art?
Nah, I'm good.
How do you define beauty?
Oh, God.
Wait.
Okay.
How do you know anything's
This one looks super fun, so let's try it. So we're going to have cosine of x minus y, so we got to use our difference identity of cosine. And then in addition, sum identity of cosine, and eventually we're going to get all that.
2 cosine
It'll be great.
of x.
2 cosine x cosine y. I hate the lack of parentheses, it just makes me nauseous, but yeah.
I'd be fine with it if they were consistent.
I know.
Like,
Yeah,
they all
they're
didn't
really
have-
serious.
Yeah, but clearly they had to put
Every way
them here because if they
possible.
put cosine of x according to their notation plus y, that wouldn't be in there.
Yeah.
But
Yeah,
it makes me nauseous.
I know. So parentheses every time, please. Thank you. All right.
Will you grade us based on
No, in fact, I was working with Evan the other day,
Yeah,
and
that.
you did the thing that I do, where I just write cosine because it's assumed that it's of x instead of cosine parenthesis x. But
But I like to write more because it postpones me from doing the actual.
from
Yeah.
thinking about the next piece, yeah.
It makes it look
True,
like
true.
it's
All right, so cosine of x minus y means that we're going to have cosine for just this piece. Okay, I'm going to move over. Yeah. All right, cosine of x, which is u, so cosine of x times cosine of y plus sine of x times sine of y. All right, so that's the first piece there. Okay, and then we're going to add to that cosine of x plus y, so that's this guy over here. So cosine of u, which is x, times cosine of y, minus sine of x, sine of y. And that is going to somehow all simplify to be just 2 cosine x cosine y, meaning all the signs are going to go away. Ooh, which we can already see they are. Because this is sine of x, sine of y, negative, and this is sine of x, sine of y, positive. And so sadly, they go away. And then cosine of x is left, cosine of y. And then another one. And if you have the same thing plus the same thing, you have 2 of them.
Really?
Yeah. So there's 1 of that and 1 of that. And so now there's 2 of that. Boom. 2.
This is the type of math I like.
I know, huh?
There's one.
Beautiful
there's two.
art. Let's write it down and let's stare at it.
But just the last one, not
The part where we say those are different, so they kill each other.
I like it. I don't like that, but I like how you get bigger and
like
smaller.
they're opposite, so they cancel, and then they're the same, so they're 2.
Yeah.
That's good.
I like when it becomes really short and you're like, oh man, I swear I could have done that. Okay.
when everything simplifies to
Like
like 1.
Yeah.
That makes
It's
me
my favorite.
Ooh.
I know. It also, yeah, makes me
It
a
makes
little
me so
nervous,
angry
just in
because you have
case.
half a page of stuff and it's like, oh,
2.
it's 1.
Yeah. Yep, sorry. So page 468 is your assignment. Yay! And we're gonna do those ones. And according to my notes, I don't need to change this assignment, so we should be good. So I should come around and check your previous assignment though, because
Remember,
apparently people did.
I agree with Lex.
I agree with, we only meet every other day, so we should probably.
I concur.
I have the first question.
Nice.
I know, sadly,
We're
it's
not
mine too.
for this one.
Okay.
The last assignment took up a lot of.